Hello guys, I have to upload this video again because the voice quality in previous video was not very good. So again I would like to emphasize that this is a video which is being uploaded after a long gap of time due to some reason, and the request was there to make a video on meshes and hernia repair. So here's the lecture, and before starting the lecture, we should know what is a mesh. A mesh is a prosthetic material used to strengthen a hernia repair. Obviously, a mesh should have properties certain also. It should be strong. It should have favorable host response. It should have good handling properties like we have read about sutures. It shrinkage or degradation over time should be negligible. It should be cost effective, and currently available meshes for the use are constructed either from synthetic materials or animal tissue. I have marked these 2 points from red because these are the most important properties of a mesh, that is shrinkage and cost effectiveness. Now, meshes can be classified into net or flat sheets, which we will study. Meshes are used to bridge a defect, that is fixed over defect without tension. They can be used to plug a defect, that is pushed into the defect, and they can also be used to augment a defect, that is defect is closed and meshes added for reinforcement. These are the examples which I have for. Suppose this is the defect and here is the bridging of the defect, which is by blue color thing. Now what is plugging? Plugging is, suppose this is the defect and you using this mesh and you close this, that is pushing into the defect. I could not get a better example than this. Suppose this is a defect, you have closed this defect by its own, and again above it you are augmenting it with the mesh. Now a mesh should have a good overlap of at least 2 centimeter, that is it should cover defect from all around at least 2 centimeter beyond the defect, but the best results are there when we cover the defect up to 5 centimeters. Edge to edge suturing of mesh is not recommended because one of the properties is shrinkage of the mesh. So if we suture the mesh from edge to edge, it will shrink and defect will increase in size. Plug operations are fast, but dense mesomer formation occurs. This is a picture of a net mesh. This is a picture of a flat sheet. The classification is gross classification. This is net. This is flat sheet. Net can again be classified into woven one or the netted ones. This is the classification on the basis of gross structure. Nets, as you can see, are porous and it allows tissue ingrowth between the strength. On the other hand, you can see sheets are non-porous and they do not allow host tissue ingrowth. Obviously there is no space, but there is a process by which they get encapsulated by the fibrous tissue and provide strengthening. On the basis of origin, they can be classified into synthetic ones and the biological ones. Synthetic ones are polypropylene, polyester and PTFE, and the biological ones are alloderm, permacol or flex HD. On the basis of absorbability, these can be absorbable or non-absorbable. One of the most important way of classifying a mesh is on the basis of weight and porosity also. So these can be light weighted, medium weighted or heavy weighted. The light weighted are the ones which are less than 40 grams per meter square, and the heavy ones are more than 80 gram per meter square. Medium ones are in between the two. Again, they can be classified into porous ones and the non-porous ones. Now, the porosity is meshes with thinner strands and larger pores between them are preferred because they have better tissue integration and less shrinkage, more flexibility and improved comfort to the patient. Before studying way to apply a mesh, we should know the anatomy of abdominal region. So this is the linea alba, this is the anterior rectus sheath, this is the posterior rectus sheath. If we go laterally, anterior rectus sheath is formed by external oblique aponeurosis, a fiber of internal oblique aponeurosis. The posterior rectus sheath is formed by the fiber of internal oblique aponeurosis and transversus abdominis muscle. So, posterior rectus sheath is formed by fiber of internal oblique aponeurosis and rectus abdominis. Now, we'll proceed further. Way to apply a mesh, there are the answers: Onlay, Inlay, Sublay or intraperitoneal. We'll learn them now. Onlay is when you are applying the mesh over the anterior rectus sheath. So this is the anterior rectus sheath. You may close it and provide a mesh covering over it. What is inlay? So, suppose there is a defect. You are not repairing the defect and stitching the margins, obviously with 2 cm or 5 cm coverage with the anterior sheath. So it is not above the anterior sheath, it is in between. What is sublay? Sublay is behind the rectus abdominis muscle but in front of the posterior rectus sheath. So this is the mesh and this is the posterior rectus sheath. It is applied in front of posterior rectus sheath. This is the IPOM. What is IPOM? It is intraperitoneal onlay mesh plasty. So this is peritoneum and we are putting the mesh in the intraperitoneal region. So on this surface we are having bowel. So here comes the importance of composite mesh, which will be reading in the end of the lecture. So this is the recap, you can say, but one more thing is preperitoneal one. So this is, retromuscular, also called as sublay. This is preperitoneal. This is behind the peritoneum but also after your posterior rectus sheath. So here it is not exposed to bowel. Now in open surgeries all the possibilities can be there of putting a mesh, but in laparoscopic one only intraperitoneal and extraperitoneal mesh placement is possible. Mesh shrinkage, you have known, this is the most important property of a mesh. It is a progressive decrease in the size of the mesh over time due to natural contraction of the fibrous tissue embedded in the mesh. Reducing the area of the mesh itself, it is a cause of recurrence. Limitations of mesh use. One of the most important limitation is presence of infection. So if mesh get infected, it often needs to be removed. So you should remember that if there is infection and there is hernia and you are operating it, mesh should not be placed. One more thing is polyglycolic acid fiber. What is that? It is a synthetic absorbable material. They have no current role in hernia repair because they absorb and induce minimal collagen deposition. One more thing about biological mesh. It is sterilized or decellularized, non-immunogenic connective tissue, but it is expensive one. Sources are human or animal dermis, bovine pericardium, porcine intestinal submucosa. Host enzymes eventually break down the biological mesh, which is replaced and remodeled with normal host fibrous tissue. So it is biological, more you can say natural, but chances of degradation are obviously there, and it is expensive also. Synthetic mesh. Example is polypropylene, which is monofilament and hydrophobic. Due to being monofilament, it impede bacterial growth, although it is not antibacterial in nature. One more is polyester. What is this? Braided filament and hydrophobic. Again, both of them are hydrophobic, but this was monofilament and this is braided. So it may allow infection because it is braided to hold. Also allow rapid vascular response to infection and providing a stronger host tissue interface. One more example is PTFE. It is a flat sheet. It do not allow any tissue ingrowth. So tissue separating on composite mass, you must be remembering by the picture which I was talking about. So these are designed for intraperitoneal use. They have different surfaces. One is sticky and one is slippery. So sticky should be away from the bowel, slippery should be towards the bowel. Usually one side of the mesh is coated with a material that prevents adhesion. This adhesion is true for bowel surface, because on the other side we want adhesion, but on the bowel side we do not want adhesion. So usually one side of the mesh is coated with material that prevent adhesion, such as examples are polycellulose, PTFE or collagen. A recent mesh made entirely of sheet of condensed PTFE with multiple perforations can be used intraperitoneally. So it is made of single material because the peritoneum will grow through perforations, whereas bowel will not adhere to inside. Early meshes were considered as over-engineered because they were heavy-weighted. More dense or heavy-weight meshes provide a greater fibrous tissue reaction, leading to collagen contraction and the shortening. Thank you so much. Any questions can be asked in the comment section, because this is a huge lecture and every point can't be covered in this one. So you are always welcome to ask questions in comment sections. Thank you.